Hey everyone, it's Miss K again. This time I'm going to be talking about heat transfer. Heat transfer is the way that heat moves from a hot object to a cold object. That's the only way that heat can move, is from hot to cold objects. Hot objects to cold objects. Okay, we have three types of heat transfer. We have radiation, we have conduction, and we have convection. I feel like you know a whole lot about the convection because we've been talking about how that happens inside the earth, but I think the word that is tripping you up is heat transfer. The transfer of heat from a hot object to a cold object. I think that's where we're tripping up here. But I'm going to go on. First, I'll start with radiation. All right, my first one here, radiation. All right, radiation is the heat transfer through space and air. Okay, so anytime if I'm not touching something but I'm feeling heat, like on a hot day, if the sun's shining on me and I feel really warm, that's radiation. So an example would be the sun. Let's drop the sun here, a green sun, I guess. The sun is shining on me, and I guess I'll be blue today. So here I am, and I'm getting warm. This heat is hitting me, and I'm getting warm. So that's radiation. Other examples of radiation would be, okay, so first we have the sun, a tanning bed, a microwave. When I am trying to reheat my food, I put it in the microwave, and there's nothing actually touching my food, but there is radiation coming from all sides in there, and it's heating up my macaroni and cheese. There's nothing touching it. It's going through the space and the air, and that's radiation. Okay, the next one we're going to talk about is conduction. Conduction is heat transfer between objects that are touching. Keyword here, touching. You have to be touching something. Remember, it goes from hot to cold. So if something's really, really hot, say I turn the faucet on and I have the hot water running, and there's hot water coming out here, and then I take my hand and I hold on to this, the hot water is going to be transferring, or that heat is going to be transferring from this hot faucet to my hand. That's a really ugly hand there, but that goes from my hand. So I'm touching it right here, and I'm going to feel warm on my finger that's touching that. Or even if I was touching the water here, if I pulled my hand and touched the water, I'm actually touching something, and I'm feeling the heat, and the heat is going from that hot water to my hand. Okay, the example I gave in class was with a stove, and say we have the burner turned on, and my mom just got me a really fancy pot set for Christmas, and it is touching right here. The coil is touching the pot right there. So the pot is going to get warm. Okay, other examples would be, let's say that I was outside on a hot day and I took my shoes off because I didn't want my shoes on anymore, and I started running across the concrete, the black tar, and it burns my feet. I know we've all felt that before. It's super hot on the bottom of your feet when you're touching that black tar because the sun radiates the heat to that black tar, and when it touches the bottom of my feet get really hot. So the heat is transferring from the black tar to the bottom of my feet. That is conduction. My feet are touching that hot thing. All right, and the last one here we're going to talk about is convection. Convection. Okay. Convection is heat transfer in fluid from one part to another due to temperature and density. Make sure your heat transfer foldable has the word density, because in one of the classes I messed that up. It is temperature and density. Another key word is fluid. So it can only be a fluid, something that can bend, that can be plastic, it can move. Inside our Earth, the mantle, as you know, is a hot, solid rock, but the asthenosphere can bend and move, and that's why it can convect. Okay, I'm going to go to a new page so I can draw this. Okay, so the example we did in class, we again had the stove, and we had my coil, we had my fancy new pot my mom just got me, and it is conducting from the coil to my pot, but the actual liquid inside here is convecting. So the convection is in here. I'm gonna blow this up down here. So I got my pot. And this is the exact same way it happens with Earth. So I got water in here, and it's hot here. So the heat in the water, it gets really hot down here. Those particles move further away. They get more energy. They become more spread out. The particles are more spread out. And it is less dense. Less dense rises. So less dense floats. And I'm talking about the particles. When something's cold, the particles are really close together. And when they get energy, such as from the heat, they start to move apart. And they have more energy and they can move around. So they're not as tightly packed, so that means that they're less dense. There's less particles in that same area as compared to down here. Okay, so it gets hot, the particles spread out, they get less dense, so they want to move up. So then they're up here, and then they get cold because they're touching the air. So then they're like, okay, I want to get hot again, I'm going to move down. And the particles become closer together because they lost all of that energy. So they lose energy, they lose the heat, they come closer together, particles close together, hopefully you can read this, and then they become more dense. More dense sinks, just like when we were talking about the oceanic crust. Oceanic crust is more dense sinks. Just think about the particles. If I have something that has more particles here, it's going to fit here. And then when I have them stacked, it's going to be the most dense on the bottom and the least dense on the top. Okay, density columns. We're finding all that time. We've been talking about density all year. The most dense sinks, the least dense floats. Okay, so this is a constant thing. Becomes less dense, cools off. then it becomes more dense, and then it wants to heat up again, and it's constantly recycling and going around this circle. And that's due to, right here, temperature and density. So it's getting hot to cold, hot to cold, hot to cold, and it's going from more dense to less dense, more dense to less dense, more dense to less dense. They go hand in hand here. All right, one last thing, I just want to draw the Earth and talk about how this convection currents happen inside the Earth. So we have our crust here. This looks like an egg. We've got the crust. I'm just going to do the main layers. This is going to be the core. And remember, it's super hot. Super hot. Maybe I should have made that red. Okay. This is the mantle. So the core works just like that coil on the bottom of the stove. The coil, and then we had our pot. The core is just like the coil. It's super hot. So when this hot solid rock comes down here close to it, the particles get hot and it moves up. And then it loses energy and it moves back down. And this is happening all over in here, constantly. It works the exact same way. It's due to temperature and density. So it is most dense down here and least dense up here. And this is the thing that's driving these plate tectonics to shift around our Earth. So we're talking about plate tectonics now. This convection current inside the mantle are moving the plate tectonics around. And that's where we come into the plate boundaries. Okay, I hope this makes more sense with the heat transfer. Otherwise, you know where to find me. Thank you.